Hi, this is Bob from INSYDIUM, and this is part 3 of our particle Christmas tree tutorial series. And in this video, we're going to take our spline wrap simulation scene, we'll make some adjustments, and then we'll create some textures in Cycles 4D, including a procedural bauble texture. We'll then have a look at some output settings, and we'll render off a test. Here we are in our spline wrap scene, and you can see where we left off. We created this flow field system of our particles moving along through this volume, and they're being attracted towards this spline, and we're getting this nice swirly movement. And you can see we've got our snow particles and our bauble particles in there as well. Then what we can do is we can take this simulation, and by activating a spline wrap deformer, we can wrap the simulating particles around our helix. Let's just switch that on, and there they are on the helix. They're still simulating here, but we're deforming their position, so now they're going around this spline. So that's looking really cool. We're pretty much there with the particle simulation. What we need to do now is set up what we're going to do to get this rendered. So the way we're going to render this is using the same techniques that we used in our other tutorial Christmas tree, our flow spline one. And we actually have that system rig in our hierarchy here in our starting scene. It's called XP System Flow Spline, and you can see it's deactivated. But what we want to do is pinch the render settings from the emitters in this system and use them on our particles in our spline wrap system. So let's do that. First of all, let's just close down the folders that we don't need open to make this look a little easier to read. All right, and then we'll open our system flow spline. And again, we'll just shut down the folders we don't need to see, so all of them apart from the emitters. Okay, so in our flow spline, we set up these cycles instance tags for both our snow particles and our light particles. And we're going to have this in our scene as well. If we have a look down at our emitters, look, we have got snow particles, we've got lights particles, and we've got our baubles. So we'll look at the baubles last. So let's just pinch these settings for emitter snow. So we'll go to our instance tag. Let's drag this down, holding control. That's making a copy. And then if I let go on my snow emitter, we've made a copy of that instance tag. And inside this instance tag, you can see, look, the objects it's referencing is 10 join objects. And this is going to be creating a bit of custom geometry for every snow particle, just so it's not as regular as everything being spheres. We can have a look at the geometry we used. If we go into our lights null here, you can see, look, we have a snow chunks geo null. And inside there are our 10 join objects. All of them have this translucent material on them, which is giving us the snow look. And if we just open up the join, it's a displaced sphere. And we can actually have a look at those because they're still in our scene. If we just dolly in right underneath our tree here, you can see, look at these tiny objects. Let's hit ND to see the lines. So there are our 10 different chunks which we're using to create the snow. And so what Cycles does, for every particle generated by this emitter, it randomly picks one of these chunks and instances it instead of just doing a sphere. Okay? So that's going to work for our snow. Let's just go to the settings, and what we'll do is we'll just remove the variation, and we'll, in the size multiplier, well, let's just leave it like that with no variation for now, and we'll do a test render in a minute. Before we do, we want to do the same thing. We want to steal the settings that we set up for our lights in our other scene. So here's the lights instance tag. Let's hold control, drag a copy to the lights. Now this one doesn't have any objects, which means it isn't instancing any other geometry. It's just going to make the default spheres, and that's fine. And on this one, we need to place a emission material for this to show up in the render. So let's go to our material manager. Here are our two materials from the other scene. We want this emission one, a light material. Let's stick it on our emitter lights like that. Okay, so now that we have done that, let's just close this down. Let's go to INSYDIUM, Cycles, Real-Time Preview, get this rendering, And there we go. We have our Christmas tree rendering in our scene. Our lights are rendering lights. And if we come in really close to this, you'll see that the snow is randomly instancing those chunks of geometry. These aren't spheres. So what I'm looking at from this is that I don't think we have enough snow particles. So we could, before we resim it with more snow particles, we could just try increasing the size of those instance chunks. So let's go to our snow instance tag and let's increase that size multiplier up to, say, twice as big, 20. So that's looking pretty good, but we're getting these kind of gaps in there. And I've just got a feeling that I'd like to have this filled out with a few more particles. So let's just switch off that real-time preview. We'll go to our emitter snow, to the emission tab, and let's increase the birth rate from what it was. Let's double it. So it's 10,000. Let's put 20,000 particles per second. We'll resim that. So now we've got loads more of those snow particles. That's looking good. Let's just go forward a few frames until we've got a decent amount in our scene so we can make a judgment. Something like that. Let's go back to our INSYDIUM cycles real-time preview and we'll re-render that. So now we've filled that out. We've got loads more snow particles. Now we've done that, I think we can go back to our snow particles instance tag and just reduce that size multiplier down a bit, maybe down to 15% to make those chunks a bit smaller. Yeah, let's just leave it on that for now. And those lights are looking very nice in our scene as well, and they're kind of helping to illuminate that snow. So that's looking good. Let's leave that for the time being. Okay, so now that we've copied those things across, we can come up to our object manager and just shut down again this, just collapse this system flow spline. We don't need to see that anymore. And now that we've sorted it out, we could also, look, remember our instance geometry. Now this is, at the moment, is going to show up in the render and we don't want that. So let's go to our lights null. Let's just make all of our snow chunks invisible there. And we can close that down. Okay, so now that should be that. So there we go. We've got our snow and our light sorted out. So now we need to do the slightly more complex operation of sorting out the texture for our baubles. So what we're going to do with these baubles is we're going to create one Cycles 4D material, which we're going to put on our emitter. And that one material is going to create 5 or 6 different bauble types, like a gold one, a red one, a shiny one, a diffuse one, glass one, that kind of thing. So let's get that set up. First of all, we can just deactivate our snow and our lights emitters. We don't need those. And let's just come forward in our scene. So we've got a few bauble particles to look at in the viewport. Okay, so something like that is going to work okay. Now what we need to do, let's go to our, let's just have a look at getting something very basic set up first. So we'll open up our material manager and we're going to create a new material. So let's click here, Cycles 4D, Surface, and we're going to choose the Principled as our base material. The Principled shader can do so many different types of material all in one shader. So let's bring in one of those. We'll add this to our emitter baubles and let's just have a look at how this is looking. So if we go to our INSYDIUM cycles real-time preview, we're going to be rendering these, but look, they're really small. And because we have no instance tag on our emitter baubles, we've got no control to scale them up. So let's stick that on. Let's highlight our emitter, tags, extensions, INSYDIUM, cycles, instance. And now we're not going to instance any geometry, we're just going to do the bog standard spheres. But look, now we've done this, we can increase this size multiplier and let's make them oversized in our scene just so we can see them clearly. All right, so there are our baubles. Let's just readjust this. It's obvious, I say this whenever I'm doing rendering tutorials, that I'm obviously squeezing all of my windows into a small 1080p screen. But when you're working, you want to maximize your real estate of real-time preview and node editor to make sure you're giving yourself loads of room to be able to see and to work. I would always use at least a dual monitor setup when working professionally. So let's just put that there. Now what we want to do is if we double click on our principled material, let's just rename it. We're going to call this baubles. And let's double click this, which opens our node editor, which will move over to this side of our interface. All right, so now we've got this set up. We have access to our nodes here. When we select a node, we can see its attributes in our attribute manager. And then we're looking at our real-time preview. So with our default principled shader on our particles, we're getting these diffuse spheres, but look, we're getting a specular highlight. We can see both the softbox, the orange one, and the blue softbox behind. So that's our default. If we wanted to change the color, dead easy. We could just click on our base color and change it to red. And now we've got red baubles. But the problem is, well, a couple of things. They look like more like billiard balls or pool balls, and also they're all red, and we want to use one shader, one material, to make all of our different colors and our different types. So here's how we're going to do it. What we're able to do is we can farm data from our emitter, and the way we do that is a node that kind of drags that particle data from the emitter into cycles. So let's right click, go to an input, and what we're going to pick is a particle info node. Let's click this. Now all of these outputs are data that's being generated by the emitter, and they're contained within each particle. So each particle has an index, each particle has a color, each particle has all these different values. So if we highlight, we can isolate these outputs in our real-time preview. So look, if we highlight the color, this is what the colors the particle emitter is generating, and we can access them in cycles. So if we just piped that color into the input color in our principled node, we're now getting those colors as our diffuse balls. So that's pretty cool. It's not how we're going to color our particles, but that's cool. Another thing we're able to do is we can access this random output from our particle, and it basically gives each particle a random color value between 0 and 1, so between white and black. And that's really useful, and we can use this to color our particles. But here there's a very important thing to consider. We are killing particles in our scene before the scene comes to an end. So we've got particles dying and we've got new particles being born. And the way in which cycles is generating these random black and white values is going to get messed up when some particles die and then new particles are being born. And it's going to show, it can show some inconsistencies and some kind of flashing between these colors in our render, which is not what we want. But we can achieve pretty much the same effect with consistent black and white colors all the way through the scene by adding some mass data to our particles. Now by default, all the particles have exactly the same mass value as 1, and as a result, look, they are all white, so they all have a value of 1. But we want to give them some variation, and the way we're going to do that is, let's just close all this stuff down for now. We can go to our emitter baubles, we can go to our extended data, to our physical data tab, and look, here is where all of those particles have been given that mass value of 1. But we want them to have a random mass value of between 0 and 1. So the way we do that is, look, we'll change this value to 0.5 and we'll put 0.5 variation. And now if we hit play, these particles, each one has a mass value of anywhere between 0 and 1. So let's just see if that's the case. We'll press pause. Let's bring up our real-time preview again. And let's bring up our node editor. Let's just adjust that so we can see those balls there. Look, okay, so if we go back to our mass output now, which is coming from our particles, yes, look, each one, we've got different black and white values. And these, because they're given on birth, they will stay the same, and these will work perfectly for what we want to do. Okay, so now we've got that, how are we going to use these black and white values to create the different colors for our baubles? Well, this is what we're going to do. If we take these values, we can remap them to a color gradient. So let's go right click, converter, color ramp. And we're going to put our mass into that color ramp. Okay, and then in our color ramp, here are the attributes for our color ramp, and we're going to add our 3 colors. So what do we want? Let's just add another knot there. So we're going to do, instead of black, let's say we want some red baubles. We want some gold baubles. And maybe a different color as well. So red, gold, and we could have some, let's have some Christmassy green baubles. So let's do something like this. Now, at the moment, this isn't going to work for us. If we pipe this into our color now, we're going to get those colors, but we're going to kind of get like a blend wherever the black and white value of our mass, wherever these black and white values sits within our gradient, it will be that color. So we're getting a range of colors from this gradient, and we don't want that. So the way we get around that is we just don't want them smoothed. We want them to be, if we go to the interpolation, highlight the knots, change it from smooth to step. Now if we right click, distribute those knots, let's select them, right click, distribute knots. Now we have them distributed evenly, and they are either red, gold or green, depending on where they sit on this black and white scale. So that's pretty neat. We can maybe further randomize this by, if we go to our color ramp, what we could do is right click and duplicate the knots, double the knots here, look. So now we've doubled those knots, we've kind of repeated that pattern, and it might just offer us a slightly more kind of random distribution of those. So that's pretty interesting. That's going to work well for us, but we don't want these diffuse looking balls. The colours are fine for now, but we want these to be metal. Well, to turn a principled default shader into a metallic surface, all you need to do is slide the metallic slider onto one. And now look, we have metal baubles, and we can increase the roughness to make them more diffuse, or we can reduce the roughness to make them more shiny. But what if we wanted some to be this more kind of diffuse and some to be shiny? Well, we can do the same principle from our mass, and we can feed that into our roughness to give us different roughness values for different baubles. So let's try that. We'll go right click, converter, we'll bring in another color ramp. This one we'll just leave black and white, and let's put our mass into here and our color into the roughness. Now what's going to happen here is the very dark particles are going to have no, well, if it's black it has no roughness, if it's white it has a full roughness, so they're completely diffuse, and we don't want that. So let's change the white knot to something that isn't pure white. So let's just reduce this down, and you see as I reduce that white knot, those diffuse ones are becoming more shiny. So maybe the diffuse ones could be something like that, and the black one we don't want to be 100% shiny, so let's change this black and make it less shiny. Okay, something like that maybe. And then again, let's take these 2 knots, highlight them and make them stepped, and we'll just pull this one out. So now we've got a bit of control. The lighter ones are the shiny, are the opaque, sorry, and the darker ones are the shiny. So if we want more opaque and less shiny, we can just pull it over this way. So now we've got far fewer shiny ones. Or we could pull it this way. And to give ourselves, again, a little bit more of a spread throughout our particles, let's just have it so most of them are, we've got more shiny than opaque. But then look, let's take right click and double our knots, and then right click and double our knots again, and now we're kind of spreading out this, so we get some red that are shiny, some green that are shiny, some green that are opaque, and now we've got a real mix of different types of baubles in our scene. So this is working fantastically. So that's that, and I'm pleased with that. But let's say we want one more type of bauble. Let's say we want some, instead of some metal shiny ones, we want some glass baubles. How might we get glass into here as well? Well, this is really cool. What we're going to do is, I'm going to close up this principled shader, and I'm going to hold Control, I'm going to copy it, and open up the copy. Now this copy isn't connected to anything. It's not connected to the surface, so it's not doing anything, but I can still solo its effects by clicking on the output. So this is what it's looking like. It's a metallic material. We don't want this to be metallic, so I'm going to take the metallic off again. And instead of metallic, we want this to be a glass. So we're going to increase the transmission. Transmission's glass, and this needs to be on full. So now we have a glass material, and if we increase the roughness, it's a more opaque glass. And if we reduce the roughness, it's a more transparent glass. So we can go right down to no roughness and it's completely transparent. So we can see what's going on, let's just make it opaque glass for now. And what we can do is we can take the same color input from our color ramp, the output, and put it into the input here, look. And now we've got our colored glass. Okay, very good. We could also take the roughness as well, should we wish. We've got different types of glass. We've got some opaque and some shiny. But now what we want to do is we want to kind of mix the glass shader with the metal shader so that we've got mostly metal ones, but every now and again we get a glass bauble. So how are we going to do that? Well, we're going to get a mix shader first that can mix these two together. So let's right click, shader, mix. And we'll take our metal one as shader 1. We're going to take our, let's just take that off, our glass one as shader 2. And then put the output of this mix shader now into the surface of our object, of our particles. Now let's just close that down. So what's happening by default is that with the factor is how you mix between 1 and 2. So on 0.5, it is perfectly mixing shaders 1 and 2 together. And that isn't what we want. We don't want these to be mixed together. If we move the factor to 0, it's just the metal ones. We're not seeing any of this glass. If we move this factor to 1, it's going to be just glass. So what we need to do is be able to drive this factor. And we're going to do that again with a ramp. So let's right click, converter, color ramp. Okay, and this ramp, let's take our mass and put it into our color ramp. And let's just remind ourselves, looking at this output, this is giving us these values. And what we're going to do now is we're going to take our black and white values. Let's just highlight those knots in that ramp again. Change it to step. So we have no grays in this now. These particles are either black or white. And if we move the white, we've got more white particles. And if we move the white long, because there's more black, we have more black particles. But these are either 0 if they're black or 1 if they're white. So now we can use this gradient, these 0 and 1 values, to drive the mix of our metal and glass shaders. So let's put the color output into the factor. And now you'll see we've got mostly metal, because most of our particles are black, which is 0, but we've got a few glass. And if we pull this white to the left, we've got loads more glass particles and hardly any metal. Or if we pull this shader to the right, so there's more black, we've got mostly metal with a couple of glass shaders. So that's pretty fantastic. In one material, we've managed to create all of these different types of baubles, and we've got control of how they are distributed in our scene. So let's close that material down. And what we need to do is adjust the size, because obviously our size isn't correct here. So with our emitter baubles, let's go to our instance tag, and we've got this way up. Let's put it on, say, 300%. So that's looking pretty good. It's hard to tell without our other particles. So let's just pause our real-time preview. Let's go back to the first frame. We'll activate our snow and our lights emitters. Let's play this through so we get loads in our scene. We can do a quick render to make sure we've got the size of those okay and we're happy with how they're looking. And then when that is the case, we can get caching our sim and sorting out a test render. So look, we've got loads of particles in our scene now. That'll do. So let's do it from there. Let's just increase the size of our real-time preview. We'll hit play. So there we go. There we have our particles. Now arguably I'd say we have too many green particles, baubles for my liking, and they're also possibly a little bit too big. Let's put this down to 250. So we've got, for my eyes, too many green baubles. So how can we address that? Let's put this back up here. Let's go to our baubles material. And this is what's driving that colour. I don't like the amount of green that we've got. It's too much. So all we need to do, look, is let's just clamp the green down. So there's less likely to have green baubles. Keep going. Let's increase maybe the red so we don't have too many gold. Okay. And that quick adjustment, come to our real-time preview. And now look, we've got far fewer green baubles. I also think those green baubles are too vividly green. Let's just take this one and I would say let's just maybe darken it down a little bit more and darken this one as well. Yeah, that's looking better to my eye. Okay, but obviously you can make whatever adjustments you want to that. Now we've got that set up, we can make infinite adjustments, but that is working really well. Excellent. So let's close down that real-time preview. We'll go back to the beginning frame. So now we can look at getting this cached up, making adjustments to that animation, and then getting our scene rendered. So let's get this cache set up. We'll switch off our material manager there, go back to the first frame. So we'll go to our system spline wrap. Let's go to utilities, choose a utility. We're going to choose a cache. We're going to cache to external files, which are saved in my instance here in my documents. And we want to just hit play. So we'll build cache. And as that's caching away, it's going to take about 4 minutes, I'd imagine. So let's pause it here. I'll come back to you when that's finished and we'll move on to the next step. And that just took 3 minutes and 45 seconds to cache, and we've got all of our particles looking good. Now, before we render, we've got a couple of issues here. The first issue is, well, look, our particles have just suddenly disappeared and some of them seem to have jumped down here. Then if we go forward a frame, they reappear again. What's going on? Well, this is because, if you remember, we used our spline wrap to deform our particles from their simulated position along this domain here to around our spline. And it is cached the particles in that new position now, but then it's trying to apply this spline wrap to them, and that isn't going to work. So all we need to do is make sure we switch off the spline wrap, because we're done with that now. They're cached in the correct position, and now we've got our particles working beautifully. Okay, so that's one of the issues. Another issue is our bauble particles, look, are intersecting perfectly our snow ribbons, and we actually would rather have them kind of floating on the surface of our snow ribbons. So what we want to do is we need to adjust them. Well, we can do that without simulating again, just by adjusting the cache. So look, let's go to our emitter baubles emitter, and we'll go to, here's the new cache tag. And if we go onto this cache tag, we can go to override the playback, and then I'm able to select local coordinates. And now I'm just able to move this emitter up on its local coordinates. So if we go to the emitter, let's go to the coordinates, and in the Y, we want to move them up a bit. Let's just put, I don't know, 5 centimeters. If we just go forward a frame, that'll activate. And now look, we've bumped them up, and now they're much more close to that surface. Now, depending on how big we're going to render these, we could maybe put them up one more. Let's put them up 1 more centimeter, say 6. And of course, we can come and make adjustments to this when we need to. once we've got all of our render settings set up. All right, so we've adjusted that. The other problem is if we hit play, this isn't quite playing in real time in the viewport, and it's already feeling too fast. So at real time, it's going to be really fast. I'm saying that we need to probably half the speed of this. So how can we do that? Well, we can do it using the same technique. If we go to the emitter baubles, to the cache tag, we're overriding the playback. We've done local coordinates, but look, we have this scale, which is effectively the playback speed. By default, it's set to 100%, so it plays it back at 100% speed. But if we put this on, say, 50% speed, you can see, look, our baubles are now playing back at 50% of their speed, perfectly smoothly, and they're obviously now offset from our snow and light particles. Excellent. So let's do the same thing for our snow and light. We'll go to our snow. Let's activate the override, and we want the offset to be 50. And let's go to our light, do the same. Override, scale 50. And now all of these are playing back at half speed, really smoothly, and we're able to retime it that easily. So let's get to a frame where all of our particles are made it up the tree. This is going to be our starting frame, so around 650. So let's go to our render settings, edit render settings. We still have Cycles 4D selected as our renderer. Let's go to the output, and we want to render from, let's say, frame 660, and we want to render for this, let's just do maybe 4 seconds. So for that we need to put it on, what, 780. That's going to give us 120 frames, which is 4 seconds. Excellent. And let's just go to our Cycles 4D. And remember, from our other scene, everything in here is in the default settings, apart from we have selected adaptive sampling. And this adaptive sampling is really cool. We have a minimum samples of 6 and a maximum samples of 20. The more samples you have, the cleaner the render, the less noise you have, the more crisp your images will be. But obviously, if you have more samples, it takes way longer to render. So you want to use as few as possible. So what this does is it looks at the scene, and where it thinks that the noise level is so great, it will use the higher end of the samples. And the way it decides whether it uses the minimum or the maximum samples is using the adaptive noise threshold. So the lower this number is, the more likely it is that it's just going to use the full samples. The higher this number, the more likely it is that it'll use the lower end of the samples. So we have set it at 0.05. I think that we, for safety's sake, could possibly have more than 20 samples. Let's use our real-time preview to see exactly how clean 20 samples is going to get our render looking. Because remember, we've got metallic rough balls here. We've got glass balls that are all going to require a certain amount of samples to make sure that they aren't noisy. So let's go to our INSYDIUM, Cycles, real-time preview. And here we go. And so you can see, look, we have 20 samples set as our maximum samples. And if we move our mouse down, look, we can see it's calculating those samples now. So let this keep calculating until we've got right through to all of those samples. And then we'll be able to analyze this scene and make a decision as to whether or not we think it's going to be good enough quality. My gut feeling is, looking from here, that we are going to be fine with this amount of samples, because it's already looking pretty clean, and we've not even got to that 400 samples yet. So yeah, so what we'll do, let's just pause that. I'm going to come in really close to some of these baubles here so we can get a really good and up close view of them, and then we can get an idea of whether or not we've got enough samples here. Now, so you can see in all of the reflections, especially in the metal, we have this very kind of noisy look. And now that we're much closer to our balls, this is actually taking longer to render. It's not going to take this long when we do our proper camera angle. But let's just see how all of these problem areas, these noisy areas, are cleaning up once we get through our samples. And again, this is getting cleaner and cleaner, and we're going to see that I'm pretty sure that when we get near our 400 samples that this is going to be clean enough for us to just leave these settings. So we'll leave it chugging away for a little bit longer. It's nice coming up this close. You can really see the difference in our baubles here. We've got, look, here's a glass one. Here's quite a rough glass one. We've got a really shiny red one. We've got this very diffuse, shiny gold. And again, the fact that we were able to really quickly set this up with only one material is very cool indeed. All right, so this is starting to clean up. Look, we're on 300 of our 400 samples now. This is getting clean. So this is definitely going to be fine. By the time we've got to 400, this is going to work perfectly well for us. Excellent. So we can just shut that down. Let's move back and let's pick a camera position now that's going to show off our tree in all its glory. So maybe something like this. Let's make that central. And there we've got that going round. So we could have, we could be fancy and do an orbiting camera, but let's just leave it kind of bog standard for now, so we get a proper idea of the animation and movement of our particles. Right, so that's looking really cool. Excellent. So what we'll do is let's go to render. We'll go render to picture viewer. Yes, we can save. We can continue without saving. We'll make that full screen. And let's just have a look at the first couple of frames to make sure we've got our adaptive noise settings okay. Because remember, the real-time preview was giving us all 20 samples all over that image, whereas in our final render settings, we've got a minimum and a maximum in that adaptive. And yeah, so I'm looking at this and thinking that this is looking a little bit noisy in these baubles, and we're getting a really fast render time anyway for these frames. So let's just try stopping this. It's only 3 seconds a frame. Let's try stopping this but increasing those minimum samples, because we've only got it on 6, which is really low. So let's do that. We'll hit file, we'll stop rendering. Yeah, let's close that down. Let's go back to our render, edit render settings, and then in cycles 4D, let's move down. And yeah, look, so our adaptive min is only set at 6, and that's just too low. Let's put this up to 13, which is going to give us loads more. Okay, something like that. Excellent. So let's go again. We'll go to render, render to picture viewer. Yes, continue without saving. So here we should have a better quality render with these. It's going to take longer to render. And of course the first frame always takes longer because it's having to load in from that cache. But here we go, it's going to start rendering in a moment, and we'll have a look at those settings and see how they look. Alright, and let's just have a look at that first frame. So this is the first frame with the lower samples, and this is the first frame with the higher samples. And it's just ever so slightly cleaner, but I'm still seeing a little bit of difference in this bauble. So what we'll do, let's close down the picture viewer. Yes, we'll stop rendering. Let's go to the render, edit render settings. And what I'm going to do, because we're getting fast render times anyway, is we're going to switch off adaptive sampling, and we're just going to have 20 samples across absolutely everything. Okay, so let's switch that off. This is going to take slightly longer to render, but should be a higher quality. So let's render to picture viewer. We'll let that run through. So again, it's going to take about 19-20 seconds to load up from the cache to get to the appropriate part in the cache where we're starting, because we're starting at frame 660. So once we've done this, we should have a better quality render. So let's have a look. Yes, you can see it's taken longer to render here because it isn't using that adaptive noise, but the result is we're going to have a much cleaner render. Excellent. Okay, so we'll leave that going, and once we have finished, we'll come back, have a look at the final result, see how it looks, and see if we need to make any more adjustments. Okay, and that's finished rendering. That took 18 minutes to render those frames. Let's just hit play, and there you can see that we've got our simulation working perfectly now. So we've got our different coloured baubles, which we set up with one material. We've got our snow chunks, we've got our lights, all working in this scene. And remember, this is only one element of the scene. This is kind of the central part of our Christmas tree with our baubles. We're going to have lots more kind of more erratic and noisy particles to include on this when we comp together all of our sims.